Today we are recording a slot car race, and I will show you how to derive interesting details from the data. Our lap counter is sending its data to a PC via the serial USB interface. The program CoolTerm allows me to write the received data into a text file. When switched on, the lap counter responds with the connection data in your Wi-Fi network. In addition to the race data, all start, stop and configuration commands are logged. Furthermore, we can send configuration commands to the lap counter via the serial interface. It is responding with this help menu in case you're sending an invalid command. So you don't have to remember any commands. The length of the racetrack, the scaling factor and the Wi-Fi credentials are saved permanently, while the names assigned to the slots will be deleted when it is switched off. We have more videos about Arduino projects on the channel, so it might be worth to push the subscribe button under the video. When starting a race, the starter sequence corresponding to the start lights is logged. And then we have the values for the track length and the scaling factor, followed by the headline for the actual race data. We get the lap count, all interesting times and the current overall average speed. In addition, we are recording 3 parameters that the counter is computing from the voltage on the tracks. In the row for the final lap, you're getting a summary for each race. This data is from our 50 laps example. The lap times from the last lap, the best lap times, the average lap times, the overall times, and the penalty times are in milliseconds. The last column shows the average speeds of the drivers over the entire race in kilometers per hour. Using a scaling factor of 24, we are getting the speed of the racing cars corresponding to their original size. With a scaling factor of 1, you would get the actual average speed of your model racing cars. So far, we recorded practically a copy of the data, which is displayed on the browser interface. We only need to do a final calculation to consider the penalty times. By the way, our lap counter is calculating this automatically for the web interface and even displays a trophy for the winner. In our example, the winner still remains the winner even when taking into account his higher penalty time. One advantage of data recording is that you have your race documented and you can later analyze each individual race lap. In case you want a deeper analysis, our additional performance indicators are of particular interest. Our system is measuring the voltage on the rails 100 times per second. The sum of that measurements gives us these values in volt seconds, which are an indicator of energy consumption. I'm calling that an indicator because for the real energy consumption we still would have to multiply it by the currents. In the next column we have the average voltages per lap. The last column gives us the maximum measured voltage. Next, I would like to show you how to analyze the data using a spreadsheet. I designed the text files so that you can import them into Excel. First, I marked the race data for a so-called pivot chart. Excel cracks know how to do it. For everyone else, I'll briefly demonstrating it. First, we need a filter for the pilots' names. We want to have one row for each lap of the race. Then we want to write the lap times and the average voltages into the columns. Down here, I don't want to have the totals as Excel suggests, but the average. We are getting a graph for the lap times together with the voltages over all 50 laps. Introducing a second y-axis allows us to display lap times and voltages in a single graph. Now I can use the filter to select a pilot. The graphic shows us already quite different driving styles. Using some Excel functions, we would like to examine this in more detail. The so-called standard deviation, also called variance, indicates the mean square deviation from the expected value, which in our case is the mean value. We apply the function to both the lap times and the average voltage values. Ideally, we would like to have a low standard deviation, because that would indicate a consistent performance throughout the race. In other words, if you drive fast lap times with a low standard deviation, then you're a good racer. Even more interesting is the correlation between the average voltage values and the lap times. The so-called correlation coefficient can theoretically take values between -1 and +1. +1 would be a 100% positive correlation between two sets of values, and -1 would be a negative correlation. In case the value is 0, then there is no correlation. Our graph shows that lap times are small when the voltage is large and vice versa. This is a negative correlation. In our case, a correlation coefficient of -1 means that we always using the power of a racing car optimally to drive the shortest lap times. In other words, with a correlation coefficient close to -1, you're not just a good driver, but a very good one. However, every small driving error prevents you from actually reaching -1. For our slot car pilots, we find the following values. Wolle pushed the throttle to higher voltages while having a lower standard deviation than Timo. However, Wolle's average lap time and the standard deviation is worse than Timo's. Timo's correlation coefficient is -0.712, while Wolle achieves -0.377 only. What are these values telling us? Wolle is the more experienced driver. His voltage level is higher and more constant. However, he took too much risk in this race and therefore has some bad lap times. Although Timo is less experienced, he delivered a safer and more efficient race, which is why his correlation coefficient is closer to the ideal value of -1. The two drivers are close in terms of their overall time, but they have different driving styles. Statistical analysis is for enthusiasts who want to document and analyze their racing data. You can gradually improve your racing skills and your vehicles, and I'm hoping that my examples are helping you on this. But no matter how deep you get into this, I hope you have fun with your DIY lap counter. Now stay tuned and don't forget to support the channel. See you soon in the coming episodes.